So, dear students, in the last lecture, we have finished used to determine an analytic function when real or imaginary part is given to you. Okay. Now, let us continue our topic. So, the next topic is what? To find analytic function when u plus v or u minus v part is given to you. Okay. Let us see. To determine or to find an analytic function when u plus v or u minus v is given. Okay, so this is your topic. So let us see how to find the analytic function when combination of u plus v or u minus v is given to you. So let us see first example. Let us see first example, then you will understand. Example: find an analytic function. Find an analytic function. Find an analytic function f of z when u plus v is equal to e raised to x in bracket cos y plus sin y is given to you. Okay, so this is your problem and we have to determine analytic function. Okay, so solution, let us see how to find analytic function. Okay, so we first write down, let f of z equal to u plus iv. F of z equal to u plus iv be an analytic function. Be an analytic function. Analytic function. Okay, here we assume that f of z equal to u plus iv be analytic function. Okay, now what I have to do the next step? Our next step is what? We multiply by I on both sides. So just multiply, then we multiplying by I on both sides. So this become f of z to I into u plus iv. Okay, so just simplify this first. We multiply this inside, so this become iu. Okay, and plus this become what? I square v. Okay, but I square is what? I am writing here I into u. I square is minus 1. So this become minus v. Okay. Now what if I name this equation number 1 and name this equation number 2? Now adding 1 and 2. We adding 1 and 2. Okay. We get, so left hand side will be added with left hand side and right hand side will be added with right hand side. So this become what? F of z plus I f of z, and this equal to what? E plus iv in first bracket and plus iu minus v in second bracket. Okay, so just simplify here. F of z is common, so we taking f of z as a common, so f of z, okay, in bracket 1 plus I, and this equal to what? See, a real part added with real part and imaginary part will added with imaginary part. So this become u minus v. This is a real part, and plus I am taking outside. So this become what? U plus v. Okay, u plus v. Now what? Now I am letting here let u minus v is equal to what? Capital U and u plus v is equal to what? Capital V. Okay. Now replace this value over here in equation number 3. So replacing this in equation number 3. So just write down putting this in in equation number 3. We get we get f of z into 1 plus I, and this equal to what? So first part become what? U, capital U, and plus I times of this part is what? V. This part is capital V. Now what I have to do? We will differentiate this function with respect to x. So just differentiate this. So f dash of z into 1 plus I, and this equal to what? Ux and plus I times of Vx. Okay. Okay. So, but we know that by CR equation, therefore, by CR equation, what is the CR equation? Equation is Ux equal to Vy and Uy is equal to what? Minus of Vx. Okay. So therefore, we will have f dash of z into 1 plus I equal to, which part is given to you? Sum u plus v is given to you. U plus v is given to you. So we will remove x. So instead of ux here vy. So let's write down vy plus I times of what? Vx. Okay. I times of Vx. But our job is what? Our job is to find Vy and Vx. So what is that? Vx is what? This one. So just write down there. Since we have since we have we have we have u plus v is equal to capital V. But this is given to you. U plus v given to you. That's what? E raised to x plus y and plus sine. Okay, this is given to you. Now what happen here? We will find derivative. So just find out derivative. So first we differentiating with respect to y. So this is vy is equal to e. So x will be constant. So e raised to x is as it is. Okay, derivative of cos is what? Minus sine y. Cos y is what? Derivative of cos y minus sine y, and plus, and derivative of sine is cos. So this become cos y. Okay. Now we differentiating v partially with respect to x. So this become what? So this become we differentiating in this time partially with respect to x. So this term will be constant. That is cos y plus sine y is constant. So derivative of e raised to x is e raised to x and cos y plus sine y as it is. Okay, as it is by Milne-Thompson's method. Milne-Thompson's method. What is the Milne-Thompson's method? We here let, so that is Vy. Vy is equal to what? Psi 1 of x comma y, and Vx is what? Vx is psi 2 of x comma y. Okay, but psi 1 of x is what? Psi 1 of x comma y we found, and psi 2 of x comma y is found. So therefore we write we write this one, f dash of z 1 plus I f dash of z into 1 plus I, and which is equal to what? Which is equal to psi 1 of x comma y, and plus, I think plus sign is there. Okay, plus I times of plus I times of psi 2 of x comma y. Okay, so now f of z can be obtained. Now f of z can be obtained by putting x equal to z and y equal to what? 0. Where where have to put where have to put this is equation number 3. Now we name this equation number 4. In equation number 4, okay, we get f dash of z into 1 plus I, and this equal to psi 1 of, instead of x we putting here z, and instead of y 0, and plus I times of psi 2 of, instead of x z, and y will be 0. Okay, so this become what? Functions of z only. This become functions of z only, but psi 1 of z comma 0 and psi 2 of z comma 0 we found already. What? Listen, where we found this one. Okay, this one. So instead of x we put here z. So this become e raised to z, and this will what? Sine 0. Y is what? 0, and cos y is 0. Okay, so just write down e raised to z. First term. First term is what? E raised to z bracket minus sine 0 plus cos 0. Okay, and plus I times psi 2y. Psi 2y is what? Psi 2y is what? So this is instead of x we putting here z. Okay, so this become e raised to z cos 0 and sine 0. Just write down. So e raised to z, okay, cos 0 plus sine 0. Let us simplify first. So this equal to what? This equal to e raised to z. Here sine 0 is 0, and plus cos 0 is 1. Okay, and plus here we write I times of e raised to z, cos 0 is 1 and sine 0 is 0. So this will what? Let us simplify further. So this becomes e raised to z and plus I times of e raised to z. Okay, so the common over here, e raised to z is common. Okay, what is the remaining bracket? 1 plus I. So therefore we can write f dash of z, f dash of z 1 plus I equal to what? E to z 1 plus I. Okay, but 1 plus I cancel. So you can write this f dash of z is equal to what? E raised to z. Okay, now integrating on both sides. So by integrating on both sides, we get if you integrating here, so derivative will disappear. So this become what? F of z, and this equal to integration of e raised to z dz and plus c, where c is the integrating constant. where C is the integrating constant. Integrating constants. Okay, so therefore we can write here f of z equal to what? E raised to z and plus c, which is require analytic function, which is require analytic function, analytic function. Okay, when u plus v is given to you. Okay, I hope you understood, students. How easy this problem? Yes or no? Abhishek, is this easy for you?
Yes, sir.
So here instead of u plus v, if u minus v is given to you, then what happen? Again, you will let here function f of z equal to u plus iv be analytic function, then multiply by I on both sides, then again add. This is equation number one and this will equation number two. If you adding both, you will get what? You will get u minus v and u plus v. Okay. Then what? You will let here u minus v equal to u and u plus v equal to v. So in this time your function will be what? U minus v. Okay. So again use CR equation and you will change that. Okay. So if you changing this, so your function become what? Ux f dash of z in bracket 1 plus I equal to ux and minus I of vx. Okay. So instead of v you will get in terms of u. Okay. The procedure is same. And just let function here first function, that is ux equal to what? Phi 1 of x comma y and uy equal to what? Phi 2 of x comma y. Okay, and use Milne-Thompson method to obtain function f of z by putting x equal to z and y equal to 0, getting, and integrate them. So again you will get this result, getting. So procedure is same, either u plus v is given or u minus v is given. Okay, nothing is different. The difference is what? Only cr in cr equation. Okay, in this time you will have f dash of z 1 plus I equal to vy plus I vx. Okay, in that time you will have f dash of z into 1 plus I equal to ux minus I times of uy. ठीक है, यहाँ तक क्लियर होगा सबको? बोलिए।
Yes, sir.
ठीक है, चलो मैं इसके बेस पे मैं और एग्जांपल आपके लिए दे देता हूँ ताकि आप प्रैक्टिस करते रहो। एग्जांपल, फाइंड द एनालिटिक फंक्शन, फाइंड द एनालिटिक फंक्शन, find the analytic function f of z equal to u plus iv when u minus v is equal to x minus y in bracket x square plus 4 times of xy and plus y square. Okay, so you have to determine the analytic function when u minus v is given to you. Okay, so this is simple exercise for you. Please do this problem at your home. Okay, the problem is very simple as I like this problem. Okay, now let us move to the our next and important topic,